Okay, so we are back for our third lesson about the Renaissance. Today we are going to focus on science and what was happening with that. So, obviously, we've discussed that science and religion have not really meshed very well thus far in our history textbook. So, that's going to push over a little bit more, I would say, into this section, but we're going to see more of a push back from the scientific community during the Renaissance. So we're actually going to see that there is going to be some brand new advancements, and actually things are going to be developed during the Renaissance that we still use and apply today. So that's a pretty big deal. Let's see here. So first of all, scientists are going to question the church. How is this going to happen? So let's talk about a few of these people. Nicholas Copernicus is our first scholar or educator who we are going to be talking about. Now, he had a little bit different view on what had been widely accepted. So he believed in a heliocentric model for our universe, which means if we take this helio, that meant the sun, and centric meant the middle. So the idea is that the sun is the middle of the universe and that everything else is orbiting around it. In terms of our religious beliefs, this was not really the fact. For them, they had previously basically been teaching that this was not true and that the earth, of course, was the center of the universe because how could anything else be the center but us? So that is basically the accepted viewpoint, and Copernicus went a totally different way with that. He writes a book called On the Revolutions of Heavenly Spheres, which is a pretty cool title of a book, but of course it wasn't very widely accepted at all. Most people rejected this theory because it violated the religious teachings that the earth was the center of the universe. So there's that. We're also going to have somebody named Galileo. Maybe you've heard of Galileo before. So he is going to create a telescope that allows him to view the heavenly bodies. It's a good telescope. He actually observes the moons of Jupiter actually orbiting around Jupiter. And so he suggests that this is the same as how the Earth orbits all the way around the sun instead of everything orbiting around us. This takes a lot of time. I want you to just think about like sort of the observation that would have to go into this to actually track the orbit of these moons around another planet and how much he had to be working on this. So he uses this data that he has collected from his very own observations and basically says, Copernicus is right. This is exactly how we are rotating all the way around the sun. And they were like, what? No. So it actually goes so far as to him being put on trial during the Spanish Inquisition, which we talked about a couple chapters ago. That was Ferdinand and Isabella. And of course, if you were speaking out against the church, you were put on trial. And so it actually comes to a point where he is really sort of being threatened with this trial and could be put to death possibly at the end of it. And so in the end, as he gets put, he's under house arrest. That was the word I was looking for. He's on house arrest and basically for the rest of his life. He does say that he's being threatened with being executed if he does not take his hearsays or his words against the church. He needs to take them back. So he agrees that he will publicly state in court that the earth stands motionless at the center of the universe. However, legend has it that as he is walking out of the courtroom, under his breath, he whispers, and yet it moves. So he accepted publicly that he was not going to be able to share his viewpoints, but definitely that did not change his own opinion of things. And he basically left that courtroom whispering, but I'm still right. So that was Copernicus and Galileo. Of course, they're correct, right? We know that today that we rotate around the sun, and that's what is basically creating our seasons, and that is obviously really important. They didn't see it that way back then. but these two guys did. Here we've got some of Galileo's sketches right here, where he is actually doing the views of the moon, which he developed from looking through his telescope, 1609. This is a long time ago, you guys. And you can see then if we actually take these telescope images here, how accurate his drawings actually were, which are pretty cool. My kids learn about these phases. One of them is actually learning about it right now in his science class at school. And so he's always pointing out like the waning and waxing gibbous, and I don't even remember what they are. This is why I could never be on the You're Smarter Than a Fifth Grader show. I don't remember these things, but look at how accurate his drawings were to what we actually see when we look through the telescope today. So it's pretty cool. Other scientists who are going to question the church and their motives and their teachings. We have Francis Bacon and René Descartes. So these guys are going to be they're going to create new methods basically for thinking about how they're going to see science. They both feel the physical world, so the actual world we're living in and the events that happen here, cannot fit in with the teachings of the church, that the religious explanations are not enough. There has to be a scientific explanation for why these things happen. And so obviously that's not going to be well received from the church. It's not going to be well received from the general public who have been taught by the church. And so this is going to definitely change some viewpoints. Bacon, he stresses that you have to do experiments and that you need to take your observations, put those together, and then you can create what your educated guess is or what your answer is if you've gone through these experiments. On the flip side, Descartes, he emphasizes human reasoning. So like using your thinking skills to be able to sort of explain how things sort of happen. It's a different way of thinking because again, before, everything happened because God made it happen. That was the explanation from the church. That didn't always fulfill all of the thinking ideas that some of these scientists had, and so they're basically taking that extra step. Now, over time, these guys and a few others are going to create something that we call the scientific method. You might have done this before. This is basically a step-by-step process that will allow scientists, people who are running experiments, to run them and be able to have a very set, defined method to do so that they can either prove or disprove something that they are working on. So it is all of these steps. We're going to go through them real quick. Step 1 is state your problem. Okay, what are you trying to figure out? Step 2, gather some information on this so that you are educated about what the issue is, so then you can move to step 3, form your hypothesis or your educated guess. A lot of people kind of forget that these two steps come first because we always feel like forming your educated guess is the first thing, because when we're younger, that's sort of our first step, but you've already done these things without maybe writing them down or seeing them. So state your problem, gather information, then make your educated guess about it. Then you are going to run your experiment. So all the way to step 4 before you're actually running your experiment. This is where you're testing that hypothesis to see if your problem is or is not going to work out, whatever it might be. You take the data that you get from that, you're going to record it, whether you're creating a chart or a graph, or maybe it's in written form. Whatever it is, you collect it, record it, and then you analyze it, which is a very, very important step, because this is where you determine step 6. What is your conclusion? Did this experiment work the way you expected it to or not? And if it didn't, then what are you going to do? Step 7 is where you actually communicate the findings. If you run an experiment in the scientific community and you never do step 7, nobody is going to know about your experiment. So this is where academic journals and things like that come into play, so that people can actually see your research, find out what you did, and then be able to maybe even apply that to research they might be doing as well. Now you'll notice that step 7 is an arrow that points back to step 1. And the reason that the scientific method is shown in this circular form is because if your experiment does not work here, when you get past here to step 7, you are going to change something, start over, and then run this again. You only want to change one factor whenever you are rerunning an experiment, because you need to be able to show that changing that one thing is what makes a difference. If you are going to change 2 things and rerun the experiment, how do you know which one actually made the difference? So obviously, running these experiments can be very painstaking and very long, because you might need to come back here and rerun it over and over and over again. So they're sort of going to create that idea during the Renaissance that we still use today. What else is going on? We are going to have some major advances in modern medicine and chemistry. So this is a huge change, particularly if you go back to the Black Death and the sort of methods that they are using to treat those patients. They weren't very good, right? They're doing bloodletting. So basically their patients are bleeding to death. They were strapping chickens to you. They were rubbing herbs and spices onto your buboes, which was not really helping. It wasn't great. So we're going to see quite a lot of advances going on here. So let's start at the beginning. The human body. So we know that Da Vinci had done a lot of drawings of the of dead bodies. He went to autopsies and worked with physicians who were performing those so that he could see how the body fit together. And we looked at one picture earlier in that art lesson of his muscles that he had drawn in the arm, and it was all the different views. You know, you had like the front view, the side view, the back view, all of that he was doing so that he could understand how to make his paintings look lifelike. Interesting. These guys are trying to figure it out so they can actually understand how the body works. So there is a book published in 1543 called On the Structure of the Human Body. And basically, this was one of the very first comprehensive full books about human anatomy and how the body sort of fit together. The guy who wrote this, whose name you don't need to know on this one, I believe he was in Italy. He attended autopsies so that he could learn about human anatomy, like some of these other physicians were too. So when he published that book, it's actually based on his actual being there and seeing it, and not just sort of the ideas of how the human body might work, which physicians were still using ancient texts from guys who wrote about how the body worked, and they didn't know what they were talking about. So it's a good thing that these guys came along and actually started to piece this together for real. So next we have got a French physician. His name is Ambroise Paré. Paré is French, like I mentioned. He actually comes up with a bunch of different things. He creates brand new surgical instruments for actually performing surgeries. That goes along with his surgical techniques right here that were brand new. They were actually helping the patients and keeping them alive. He has an ointment for preventing infection. Neosporin, anybody? Still use that today. He also did a ton of work on artificial limbs, which blows my mind. We obviously use those methods today. They've been adjusted for more modern medicine, but the fact that this is something from the 1500s that we still use today is kind of a big deal. So Paré is the one who's developing some of those things. We have an English scholar named William Harvey. He is the first one who accurately wrote about blood circulation in the human body. So he actually is the person who shows that the heart is actually pumping, so it's actually making that constriction and it's pumping blood all throughout the body. He understood how veins and arteries worked, which direction that your blood went out through your body and had oxygen in it, and then it returns back to the heart so it can be reoxygenated. It's really fascinating for something from the 1600s. And then we have got a Dutch inventor. His name is Anton van Leeuwenhoek. I always say his name wrong. Van Leeuwenhoek. He is the first person to look at cells and microorganisms under his cool microscope that they had microscopes, he made it better. So the fact that we are seeing something that is that tiny for the first time and understanding that that is what our bodies are made up of and other objects are made up of is really a huge jump from what they were actually studying about the human body before. So all of these guys have got a massive impact on modern medicine that we still use today. They are from all over, which I want to point out to you guys. It's not like there's one country where they were coming up with all these things. These guys are working independent of each other. They're not working together. They're in different places. They're in different time periods. They might be able to use some of the previous people's information to help guide their research, but it's interesting how they put all of that together. So here we have got some of Da Vinci's drawings. This is similar to what we looked at when we talked about his art. You can see all of those muscles and the long muscles and how they fit together and how the chest muscles come over here to the shoulder and all the way up the neck. It's actually pretty fascinating from the 15 or 1600s. This is a painting from this time period, which is kind of funny looking because it's literally a bunch of people standing around a dead body. But you can see that the guy who's instructing them has got the skeleton here and how he's pointing out here stuff that they're actually seeing inside of this. This is an autopsy. So they're performing this on a dead body. And today we perform those to try to figure out maybe how somebody has died. Back then they're using it to actually encourage the knowledge so that maybe they can keep people from dying in the future if they can figure out what is wrong with them. So this is a painting from the time period, so it shows that they were actually doing that work and trying to learn. So more medicine and chemistry. I want to introduce you to Robert Boyle. Boyle is really our first chemist. So we had previously groups of people called alchemists, and they were sort of chemists. They sort of mixed things together and created these sort of potion-y type things. They believed that substances could turn into other substances. So one of their biggest thing was always to try to turn other metals into gold. And obviously that's not really how that works with the compositions. But Boyle does figure out a whole lot of things. So he figures out that all matter that we have is composed of tiny little particles, very accurate, and they behave in knowable ways. And this is true too. So if you get into chemistry, even if you're doing some in bio class, the protons and the neutrons and everything, we know how those will react with each other and how they attach and how they repel each other. So he figures that out a long time before you and I are doing it in our chemistry classes in high school. That was in the 1600s for him. He also is the one who distinguishes between what our individual elements are and what our compounds are. So he understands that oxygen and hydrogen are two separate individual things, but if you put them together to create H2O, now you have a chemical compound for water. So he's the guy who actually figures that out. Again, very interesting that it's in the 1600s when not that long before they're treating the Black Death by strapping a live chicken to you. Serious medical advances going on here, serious scientific advances. So it's kind of a big deal. We use him as modern day chemistry. He is the basis for it. We can thank him for it. A few years ago, somebody told me that they tried to remember his name by using the word boil. So obviously spelled differently, but in chemistry class, you boil things in the little beakers. So I don't know if that will help you. I told them I'm going to tell every class ever since then about that. So then we have got Isaac Newton. So Newton is the guy who comes up with the theory of gravity. So he says not only does gravity keep us on Earth, but gravity keeps everything in orbit in the atmosphere, and that's what keeps us working. He was 24 when he comes up with this theory. They say that maybe one of the ways he figured it out was when an apple fell off a tree and hit him in the head. They don't actually know if that's true or not, but that was what got him like thinking, like, why did the apple fall? It disconnected from the tree, but what pulls it down? They say that's why. I don't know if it's true or not. It will take him about 20 years to go through with this theory and actually perfect it and figure it out. He will publish books about it. Of course, people back then, some of them don't listen to him, but we still use these theories today. Other theories of his include calculus, so a lot of math, not my favorite. But this was actually partially developed by him to be able to explain some of his laws, laws of motion, for example, that an item that is in movement or in motion will stay in motion. So those are big deals that we still apply today because obviously they are accurate to this day. So science makes some massive, massive improvements during the Renaissance. And while I feel like my favorite part is still the art and the architecture because it's always my favorite part when we study, I think that the science might be one of the more important turning points in history because not only are they coming up with all of these very accurate and successful theories, but they're doing it in a time period where literally just studying science was a danger to their life. And so the fact that they stuck with it and pushed through and created all these things that we still study today in science classes and apply to real life is actually pretty fascinating. And it's a big, huge nod to them that we still study these things today. And it was pretty impressive that they managed to pull through all of that with that threat hanging over them pretty much at all times.